You walk into your kitchen at night. You reach for the light switch, and before your finger even makes contact, they're already gone. Not running, not startled, not reacting. Gone. Like they knew. Most people chalk it up to instinct, to speed, to just being a cockroach thing. But here's what nobody tells you. The cockroach didn't react to the light. It reacted before the light. And when you understand how, you'll realize that what's living in your kitchen isn't just a pest. It's one of the most finely tuned sensory machines on the planet, running software that evolution has been perfecting for over 300 million years. Tonight, we're going inside that system. And I promise you, by the end of this video, you will never reach for that light switch the same way again. Let's start with the moment itself. You approach the kitchen, you reach for the switch, the cockroach vanishes. Here's what everyone gets wrong about this. Cockroaches are not reacting to light. By the time the light hits their eyes, they are already 3 body lengths away. What they are reacting to is you. Specifically, the air you push in front of you when you move. Think of it like this. Imagine you're standing in a swimming pool. The moment someone jumps in at the other end, you feel the wave before you see them move. That's essentially what the cockroach is doing, except its pool is the air in your kitchen, and its sensors are impossibly more sensitive than any wave you could feel. At the base of a cockroach's abdomen are 2 appendages called cerci. These are essentially biological wind detectors, covered in hundreds of ultra-fine hairs, each one connected directly to the nervous system. Think of them as the cockroach's early warning antenna, permanently on, never switched off. These cerci can detect air movement as small as 1/10 the width of a human hair. To put that in perspective, that's the difference between still air and the faintest disturbance created by a human body moving through a room. So when you walk toward the kitchen, before you touch anything, before the light comes on, before you make a single sound, you have already announced yourself to every cockroach in that room through the air your body displaces. You didn't sneak up on it. You sent a message ahead of yourself. Here's what I want you to think about for a second. You have been trying to sneak up on something that feels you walking toward it from across the room. That's not a pest problem. That's a physics problem. And it gets stranger. Once those cerci pick up your air displacement, what happens next is where it gets genuinely extraordinary. In most animals, including us, a signal travels from the body to the brain. The brain processes it, makes a decision, and sends a signal back to the muscles. That whole process takes time, precious milliseconds. The cockroach doesn't have that problem because the escape signal from its cerci doesn't fully wait for the brain. Think of it like this. Imagine if every time someone tapped your shoulder, your legs started running before your brain even registered the tap. That's essentially the cockroach's escape system, a biological shortcut that bypasses the processing delay entirely. Scientists call this a cerci escape reflex circuit, a hardwired neuro shortcut that goes directly from the cerci to the leg muscles with minimal brain involvement. The result is a cockroach that goes from completely still to full sprint in less than 50 milliseconds. For reference, the fastest a human can consciously react to anything is around 150 to 200 milliseconds. By the time your brain has even registered that you saw a cockroach, it has already been running for 4 times that duration. And it doesn't just run randomly. The escape direction is calculated too. The cerci detect which direction the air disturbance is coming from, and the cockroach launches in the opposite direction automatically. It doesn't think about where to go. The physics of the threat tells its body where to send itself. Now here's where it gets personal. The cockroach that vanished from your kitchen tonight, it didn't go somewhere random. It went somewhere specific, a place it has been going every single night. Cockroaches are creatures of extreme habit. They establish fixed routes through your home, specific paths along walls, through gaps under appliances, and they run those same routes with mechanical consistency night after night. This behavior is called thigmotaxis, a need to keep their body in constant contact with a surface while moving. Think of it like a subway system built inside your kitchen. Every cockroach in your home is running its own line. Specific stops, specific gaps, specific destinations, and the route has been memorized so completely that it can run it in total darkness at full speed without a single error. And here's what makes this deeply unsettling. Those routes are marked.
Cockroaches leave a chemical trail called an aggregation pheromone wherever they travel. It's invisible to you, but to every other cockroach in the building, it is a lit highway. Which means the moment one cockroach establishes a route through your kitchen, it has permanently signposted that route for every cockroach that comes after it. You don't have a cockroach problem. You have a cockroach infrastructure problem. Stop for a second and look at the gap between your kitchen counter and the wall. That space you've never thought about once, to a cockroach, that is a highway entrance with traffic. Once the cockroach reaches that gap, what it does next should not be physically possible. A cockroach can compress its entire body to roughly 1/4 of its normal standing height. In real terms, if a cockroach stands 14 millimeters tall, it can squeeze through a gap of just 3 millimeters. That's approximately the thickness of 2 stacked pennies. And it does this at speed. Researchers at UC Berkeley found that cockroaches can compress and run simultaneously, flattening their body and maintaining near full running speed at the same time without any measurable loss of pace. The secret is their exoskeleton. Unlike a rigid shell, cockroach exoskeletons are made of overlapping plates connected by a soft, flexible membrane. Think of it like a suit of armor designed to fold rather than break. The body doesn't crack under compression, it simply reorganizes. And their legs, which splay outward when compressed, generate horizontal force that actually accelerates them through tight gaps rather than slowing them down. The gap that you assumed was too small is not a barrier to a cockroach, it's a door. Here is the detail that most people have never heard. Cockroaches have a cluster of nerve cells in their abdomen that functions almost like a second brain. Not a metaphorical second brain, a literal secondary nervous system capable of processing information and coordinating movement independently of the main brain in the head. Think of it this way. Imagine if your legs could keep running even after your brain stopped working. That's essentially what this escape system is.
In fact, a cockroach can survive for up to a week without its head entirely. The head dies from dehydration eventually, not from the absence of a brain, because the secondary nervous system keeps the body functioning. What this means practically is that a cockroach's body is running multiple parallel processing systems simultaneously. The cerci feeding wind data, the eyes feeding light data, the antennae feeding chemical and contact data, all being processed at the same time by different parts of its nervous system. It isn't a simple creature reacting to one thing at a time. It is a multi-channel sensory processor that has been miniaturized by 300 million years of engineering into something you're trying to kill with a shoe. A cockroach can lose its head and still run from you for a week. Let that sit. While we've been talking about the cerci on its abdomen, the cockroach has an entirely separate sensory system working at the front of its body. Those antennae are not just feelers, they are chemical laboratories. Cockroach antennae are covered in thousands of sensory receptors capable of detecting specific chemical compounds in the air, including carbon dioxide, which every human exhales with every single breath. Think of it like this. The cockroach has a CO2 detector built into its face, and you are a CO2 generator that has just walked into the room. It doesn't need to see you. It doesn't need to hear you. Your breath alone is a location signal broadcasting your presence to every antennae in the room. And it gets more specific than that. Research has shown cockroach antennae can detect individual fatty acid compounds present in human skin, meaning they can potentially distinguish between different humans based on scent alone. Your kitchen isn't neutral territory that a cockroach occasionally visits. It is a space that has been chemically mapped with your specific scent embedded in it, and the cockroach knows exactly where you have and haven't been based on what it smells. Here's the final piece, and this one changes how you think about cockroaches entirely. Everything we've talked about, the cerci, the escape reflex, the compressed exoskeleton, the secondary nervous system, the chemical antennae, none of it is new. Cockroaches have existed in essentially the same form for over 300 million years. They were here before the dinosaurs. They survived the extinction event that wiped out the dinosaurs. They have outlasted every predator evolution has thrown at them because the system works. It has always worked, and evolution has had 300 million years to make it work even better. The cockroach in your kitchen is not a primitive creature. It is the final product of the longest-running survival experiment in the history of animal life on this planet, and every tool it has, it earned. You have been sharing your home with a 300 million-year-old design, one that feels you before you arrive, runs before you act, compresses through gaps you didn't know existed, and marks every surface it touches with invisible signals you will never detect. So let's go back to that moment. You walk into the kitchen, you reach for the switch, and they're already gone. Now you know exactly what happened in that fraction of a second. Your body pushed air across the room, the cerci felt it. The escape circuit fired before the brain even voted.
The legs launched in the calculated opposite direction, the body compressed through a gap in the wall, and the chemical trail it left guided it home through total darkness at full speed. All of that happened before the light came on. All of that happened in the time it took your finger to travel 2 inches and touch a switch. The cockroach isn't surviving in your home despite you. It's surviving in your home because of the 300 million years it spent preparing for something exactly like you. And tonight, when your kitchen goes dark, it will be back. It already knows the way.